I can hear that all the way at my desk. So we're looking to simplify some of this stuff, so we got to remember our simplifying rules. That's going to come up repeatedly. How can I simplify this one? That'd be exactly my plan. I'm going to split it up in the cube root of 125 and the cube root of x to the fourth. What is the cube root of 125? 5. Gorge. How can we simplify the cube root of x to the fourth? Yeah. I can split this up x cubed times x, because the cube root of x squared is just x, and then we're going to have a leftover cube root of x. We can't do anything with him because my power is smaller than my index. But the cube root of x cubed, that's just 1x. Bless you. All right. On the 1 to the fourth, how are we going to wind up splitting this up, the fourth root? Yeah, let's do this into the fourth root of 32 and the fourth root of x to the eighth. And we'll need to split up this 32 because it's not a perfect fourth, but does it have a perfect fourth in it? 16. This is 16 times 2. So we split that up into 16 times 2. We can do the fourth root of 16, which is 2. And we have a leftover fourth root of 2. How about our fourth root of x to the eighth? What does that simplify down to be? X squared. So all I'm going to do for my last step down here is rewrite it so that my pieces that are not in a radical are in front of a radical. So we're going to have 2x squared fourth root of 2. So this is what we worked on Friday of last week. Okay. Questions on either of those two? Okay. What we're going to do today is we're going to start looking at operations on radicals. We're not doing surgery, but we are going to be doing some adding and subtracting to start. So I have, again, a paragraph in the textbook. It does actually have some useful information. So radicals can be added or subtracted in the same manner as monomials. If we don't remember what a monomial is, we talked about that in polynomials. It's a single chunk. They can be added or subtracted if both the index and the radicand are the same. And so here's kind of two little practice ones. And we're going to see what they talk about with our radicand being the same. Remember, our radicand is the piece under the radical. So if you think back to when we found all of our pieces, we had our radical, our index, and our radicand is the guy underneath. I'm just going to put an A. So for all the pieces we want to add together, the radicand has to be the same. And then we just add together their coefficients, so any number in front. So on this first one, it says the square root of A plus 2 square root of A. That's the same as saying 1 yellow block plus 2 yellow blocks is what? 3. If I have 1 square root of A plus 2 square root of A, we have 3 square roots of A. Then we're going to look at the bottom one. I have the square root of B plus 2 square roots of C. Are B and C the same thing? No. So we cannot add them together. That is what we mean when we say the radicand has to be the same. The guy under the radical has to match. If they are different under the radical, we can't add them together. So the way that this one simplifies is it just straight up is what it was. Square root of B plus 2 square root of C. C, not 3. So we can only add them together when their radicands are the same. And then it's just like it would be if it was 1x plus 2 x's, or 1 apple plus 2 apples, or 1 yellow block plus 2 yellow blocks. And we're going to practice this several times. Okay. So more often than not, we're going to see problems that look like this. I've got 4 square root of 2 plus 3 square root of 2 minus 2 square root of 2. And here we can see all of our radicands are the same. I've got square root of 2, square root of 2, and square root of 2. Since these all match, we can deal with our coefficients and just keep our blue block over here. So if I have 4 things plus 3 things, how many things do we have? 7 things. 7 square root of 2 minus 2 square root of 2. So if I have 7 square root of 2 minus 2 square root of 2, how many do we have left? 5. 5 square root of 2. You don't necessarily have to do this in 2 steps, but I felt like it was easier for me to show you what we were doing here, because we did 4 plus 3 to get our 7. And then we did our 7 minus 2 to get the 5. So as long as your radicands match, we're just working with our coefficient. Just working with the number in front. On the right-hand one, we need to be careful because not all of our radicands match. I have square root of 3, square root of 2, and square root of 3. So which ones can we add together? The ones with the square root of 3. So if I have 2 square root of 3 plus 3 square root of 3, how many do we have? 5 square root of 3. Switch that to purple. And then that minus 6 square root of 2 is just going to hang out because I can't do anything with it. I don't have any like ones that I can combine it with. So it's just like combining like terms. They're just really weird looking terms. Questions on this one, because it's about to kick up a notch. Not a giant notch, but a notch nonetheless. After we have this mystical discussion.
Pardon this interruption.
I have no idea if the interview goes. You go today?
For Group F, please report to X214. Thank you.
The guy did not check my email this morning. Okay. So this is all well and good when they give it to us in this lovely, fully simplified, everybody already matches answer. That ain't always going to happen. Sometimes they're going to give you stuff like this. It don't look like nothing matches either. And what we have with something like this is we have to come in and see if we can simplify each of these before we can go on. So we're going to look at each of these pieces to try and simplify what we can do. So we've got the square root of 45x. We're looking at square roots. Is there a perfect square inside of 45x somewhere that we'll be able to pull out? I heard it whispered briefly. 45 don't divide by 2. I heard somebody whisper it. What's a perfect? Yeah, 9 times 5. 45 we can write as 9 times 5. We like that because 9 is a perfect square. So we can pull out that perfect square and have this be 3 square root of 5x, which is definitely more simplified. Let's keep going with the rest of our stuff and simplify and see if we can figure out why we want to do that. Square root of 12. Is there a perfect square inside 12? 4. This is 4 times 3. So we can do that square root of 4 to get 2 square root of 3. And I'm going to bring down this plus that was between them. I'm going to bring down this minus. And then we have one last one here. We've got 20x. Is there a perfect square inside 20?
5 times 4.
5 times 4. 4 times 5 times x. We can do the square root of 4, which is 2. And then our leftover pieces here are the 5x. Now do we have something in here we can simplify? Yeah. I've got 3 square root of 5x minus 2 square root of 5x, which leaves us how many square root of 5x's? Just 1. 1 square root of 5x. And then the other one just plops on down, plus our 2 square root of 3. So I mentioned on Friday, we're going to use simplifying a lot. Here we go. We're going to have to simplify each of these down as far as we can and then try and add and subtract them together. Because right off the bat, this didn't look like we had anything we could do. But we definitely did. Okay. Questions on this one? So let's look at this one. Same vibe. This is all subtraction stuff, but it's the very same vibe. On this first one, does it have any perfect squares we can pull out of square root of 6? Does 6 have any perfect squares in it?
3 and 2. Wait, no.
I was going to say, those do multiply to make 6, but are either one of those perfect squares? Nope. So this one's just going to plop on down. Shortcut. We don't have anything we can do with it. Minus 2 square root of 6. How about our square root of 54? multiply and make 54. Might have a perfect square in it. Yeah, 9 and 6. 9 times 6 is 54. So when we take out that square root, we have that 3 that's out in front, and we've got that 3 we just found with the square root of 9, and we have that leftover square root of 6 inside. So if the 3 was multiplied out front, and now we have another 3 multiplied out front, what is the grand total of things multiplied out front? 9. Square root of 6. So we're going to be super duper careful when we are simplifying these. It's really important that we get them simplified accurately. How about this square root of 18? What perfect square can we pull out of the square root of 18? 9 times 2. So this is going to wind up as the square root of 9, which is 3. Square root, not purple. That was silly. 3. Square root of 2. So when we're looking to combine things together here, we can only combine them when they have the same radicand. So which ones can be combined together? Yeah. My negative 2, square root of 6, minus 9, square root of 6, which gives us how many? Negative 11. They're both negatives. Square root of 6 minus 3 square root of 2. So this one tosses kind of a new wrench in here with us because this one had a coefficient in there. It's going to lead us quite nicely into the next bit. We kind of got our feet in with us adding and subtracting. They have to have the same radical. If we've done adding, we've done some subtracting. Oh, now we're going to do next. Maybe some multiplying. Okay, because that's exactly what we're going to talk about next, is multiplying radicals. So if we get two pieces like this and we're asked to multiply them together, what we're going to do is we're going to multiply the coefficients together. So we're going to take the things outside. And we're going to multiply our radicands together. B times D. I'm going to not make those B circles. I don't like that. I'm going to highlight those. There we go. And then we would need to simplify. So those are our steps going to come through here. 5. And that's what I have written out down here. We're going to multiply the coefficients, multiply the radicands, simplify as much as we can. Those are our steps for working with multiplication. So that when we get a statement that looks like this one, 3 square root of 5 plus 2 square root of 15, what I'm going to do is I'm going to put one radical down below. We're going to have our 3 times 2 on the outside. We take our coefficients out front. And we're going to take our radicands together underneath. We're going to have 5 times 15. So we multiply our coefficients out front. We have our radicands underneath. We're going to need to simplify. So 3 times 2 gives us 6. Square root of 5 times 15 is 75. And then we need to see if we have any more perfect squares we can pull out of that square root of 75. Because I could rewrite the square root of 75 as what? What perfect square can I take out of 75? 25. 25 times 3. So I can simplify out the square root of 25 to get our 6, 5, square root of 3. The square root of 25 is 5. That's how we got that part. And then our very last step is to do our multiplication out front again. 6 times 5 giving us 30. Square root of 3. And there are a few different places in this process where you can stop and simplify. And I don't care where we do which steps. You can kind of take these all in a bowl and shuffle them. You just drop it down. He stays with it. Up here, you don't necessarily have to multiply it all the way out. We could also notice that this is 5 and 5 times 3 to pull our perfect square there. But it doesn't like really matter where you do our simplification stuff, which order you do these steps in. Okay, we're going to do another one like this. The one on the right is very much like this. We've got 4 square root of 12x times 3 square root of 3x. We're going to have a radical. And I'm going to take my coefficients. I'm going to have my 4 and my 3 outside. And then under the radical, we put both our radicands. 12x and 3x. So then we're going to simplify. My 4 times 3 becomes 12. Then we're going to have our square root of 12x times 3x. I was going to say, I think you jumped a step on me, but yeah, we're headed there. So we've got our 36x squared. So I've got my 12. My square root of 36 is what? 6. My square root of x squared is x. So we have 12 times 6 times x. What is 12 times 6? 72x. So these, again, they look kind of super duper complicated, but I promise we've worked with stuff just like it before. Okay. So there's lots of those on the homework that I passed out on Friday. And I want you guys to have time to work on it and practice with it and ask questions on it, on all that jazz. So I have one more, but honestly, I hate it. So I'm going to say, never mind. Just looking at the last slide I made, I'm going, it's ugly. I don't want to do it. I really don't. It's a Monday. It's 7 o'clock in the morning. Nope. I can show you the really gross one if you want to, but it was a 5th root. Yeah. Okay, so finish up, and you guys have the rest of this time to work on homework 6-5. Okay, that's the one I passed out on Friday. So if you need another copy of it, I have them in the gold folder by the tree right by the door. But yeah, kind of a chill start to the week. I like that.